All right, all right, all right. Here we go. This is lesson 4, unit 2, lesson 4. Again, we're dealing with factoring, and so we are factoring a bunch of different stuff. Let me kind of make a rundown list of what we know right now, and I'll get into what we need to know for today. All right, so the different types of factoring that we know right now, and how do I identify what to do? Right, so the first one is GCF, where we multiply out numbers and letters. And that one is the wild, wild west. I don't know how many elements that are in. It could be 1, it could be 2, it could be 3, it could be 4, it could be 5. I don't know. And so there's a bunch of different types of elements in that one. So stand by on that. That one's just kind of up in the air, and you'll just kind of have to recognize this. However I do recognize this, this is usually when numbers are really, really, really large. Okay, large numbers. Or if you notice that all of the numbers are even, or something like that. If all of the numbers are even, or if you have really weird exponents. Like, or letters that are weird. Like if you have like a W to the 6th or something like that in there, chances are there's going to be some sort of GCFing going on. All right, if you have like weird letters that you don't usually see, or exponents that you don't usually see, like anything like 4 or above, usually that's like an indicator of a GCF going on. All right. Next, we have a simple ABC. Okay, and that is going to be 3 elements. Okay, 3 elements. And so what that is going to look like is that is going to look like an x squared x normal number, okay? And there will not be a leading coefficient. There will not be a number in front of that x squared. So simple ABC is an x squared x normal number, 3 elements, and there will not be a front number that's there. Okay? Next thing that we can look for is a complex ABC. Again, a complex ABC will be 3 elements. And it's going to be an x squared x normal number. However, there is a front number. All right, so it's an x squared x normal number, just like a simple ABC. However, there is a front number that doesn't go away. Okay, next is grouping. And grouping is 4 elements. Most often starting with an x to the 3rd. So let's see if I can create one just off the top of my head. So it'd be something like a 3x to the 3rd. Actually, let's make that a different number. 2x to the 3rd minus 6. Sure, why not? Yeah, 2x to the 3rd minus 6x squared minus 5x plus 15. 1 and 3, 1 and 3, 1 and negative 3 more specifically. Yeah. All right, so it'll be 4 elements, 4 elements as such. And that is grouping. Again, if you need to know how to do grouping, I believe that is video of lesson 2.2. Okay, that's under video 2.2 if you want to look at that. Complex was, I think it's under assignment 2.3. Simple ABC, I think, is 2.1. And GCF, I think, is also assignment 2.1. If you want to take a look at those videos. Okay. With grouping under video 2.2, we did kind of talk about something that we're going to talk a little bit more about today. We're going to get today in depth, and that is the difference of squares. All right, and how do I identify if there's two elements? And then we are going to do the sum and difference of cubes. Okay, and again, that's going to be two elements. All right, and so squares and cubes are going to look similar. However, the obvious difference is that squares are squares and cubes are cubes. Squares are squares and cubes are cubes. And so what a difference of squares is going to look like is they are going to have to be perfect squares with a minus in the middle. Okay, thus it has to be a minus. Okay, so two elements, so two numbers, and it has to be a minus in the middle, and everything has to be a perfect square. So for instance, a 4 is a 2, an x squared is an x, a 25 is a 5. Okay, that is a difference of squares, and it has to be a minus in the middle. Again, we're going to talk a little bit, we're going to be talking about that again today. Cubes is the same idea, but they have to be perfect cubes. And I believe if you take a look at the factoring sheet, there's cubes up there to kind of help you identify some of these things. So for instance, we could have 27 x to the third plus 125. Okay, notice how you do not have to have a minus when it's cubes. Squares, you have to have a minus. Cubes, you do not have to have that be a minus. So this is a 3x and a 5. Okay, those are the cubes of 27x to the third and 125. Okay, and that'll get you started. So we are looking at difference of squares and sum and differences of cubes today. Okay, let's talk about those squares first. Okay, so the difference of squares. Again, there's going to be two elements, and they have to be perfect squares. Okay, so that is the lay of the land. They have to be, there's going to be two elements, and they have to be perfect squares with a minus in the middle. Okay, a minus in the middle. Okay, so an example is 9x squared minus 64. Okay, what you do to accomplish the difference of squares, if you do have all perfect squares with a minus in the middle, is this. You square root everything. Okay, you square root everything. So 3x8. Square root everything. Write it twice. All right, so 3x8. Scooch it over here. 3x8. Write it twice. One's plus, one's minus. 1 is plus, 1 is minus. So plus, minus. Huzzah. There you go. Difference of squares. So if you have perfect squares, there will be two elements. Perfect squares has to have a minus in the middle. Square root it, write it twice. 1's plus, 1's minus. That's a difference of squares. Okay, again, we talked about this a little bit before, and I think it was in video 1.2, I think. But here we're looking at it a little bit more formally. Okay, the other part of today's lesson is this. It's going to be cubes. Again, it could be a difference of cubes or a sum of cubes. It doesn't really matter. So cubes in general. So what you'll have to notice, it's going to be two elements. And they are going to be perfect cubes. So not to the second power, but to the third power. Okay, it doesn't matter if there's a minus or a plus. Like the squares, it has to be a minus. Cubes, it could be anything. So a perfect cube, for instance, is the number 8. X to the third is a perfect cube. And so is the number 125. Okay, and again, the middle could be anything. It could be plus, it could be minus, it could be anything. All right, so this is an example of cubes. There's two elements, and everything about it is a perfect cube. All right, so when you have perfect squares, you square root everything. When you have perfect cubes, you cube root everything. So that's step number 1. Get the idea. Cube root everything. So that means this is a 2, this is an x, and this is a 5. You cube root. If you don't know how to cube root, or if you're anxious about this, you can use your Desmos calculator. How you find a cube root is this. If you see my cursor down here, it's that N root button. If I click on that N root button, the cursor appears on the top of the check mark. If you want to cube root, you have to put a 3 right there. Arrow over 1 and put in the number that you want to cube root. For instance, 8. Cube root of 8 is 2. The cube root of 125 is 5. Okay, don't worry about the symbol. Don't worry about the plus or the minus. Again, we'll worry about that later. All I'm looking at is the 8, the x, and the 125. So 8 is 2, x to the third is x, 125 is 5. Okay. So squares, you would just write it twice. Cubes, you're going to have to get a little bit more tricky. This is where it gets a touch complicated. Right? Here's where I define this as square out. What I mean by that is square the outsides. Square the outsides. So what I mean by this is this. So I take this number, 2x and 5, right? 2x and 5. I'm going to write it down here, 2x and 5. What I do is I square the outsides. So of the second piece, I'm going to square these outsides. So 2x and 5 get me going, and so the outsides are now going to be 4x squared and 25. So square out. Square out. And then multiply to the middle. Multiply to the middle. So again, 2x and 5, I multiply to the middle. 2x times 5 is 10x. 2x times 5 is 10x. So square out and multiply to the middle. So you cube root everything, square out and multiply to the middle. Okay, now, the obvious missing piece now is all of the pluses and the minuses. What symbols go in here? What symbols? Is it a plus? Is it a minus? Is what's going on here? So I cube rooted, square out, multiply to the middle, square out, multiply to the middle, and then, this is usually the kid's favorite part, is I use SOAP. SOAP. SOAP, S-O-A-P, SOAP. And this lets you know the symbols. SOAP is an acronym for the same, opposite, always positive. And that lets you know the symbols that you go. So this is going to be SOAP, which stands for, let's get a different color here, orange. Same, opposite, always positive. SOAP. So the original problem has a plus. The original problem has a plus. So the first symbol is going to be the same. It's going to be a plus. The next one is going to be opposite of that. So that's going to be a minus. The last symbol is always positive. Plus. And that is how you do cubes. So squares, there's going to be two elements, perfect squares. With a minus in the middle, has to be a minus in the middle. So square root, write it twice, one's plus, one's minus. Cubes, two elements, but they're obviously cubes. So you cube root, square out, multiply to the middle. So again, you square root, creating these numbers. Okay, you square out, so 4x squared, 25, multiply to the middle, 10x, and then use SOAP, same, opposite, always positive. Okay, let's take a look at some problems. Okay, so here I have two elements, and this is kind of an indicator that this is most likely squares. So two elements, squares, which they are. And again, if you're confused by what the square root would possibly be, you can use your Desmos calculator. The square root is this square root right here. So you can go square root 144. That's 12. Square root 25. 5. Okay, so if you get lost, you can use your calculator. So this is going to be 12x 5. Write it twice. One's plus, one's minus. That's the difference of squares. Two elements, squares, minus in the middle. 196 is 14, x squared is x. Write it twice. One's plus, one's minus. Squares, and again, if you get lost, you can use your calculator. So I don't know, but I'm assuming that 196 is a square root, and indeed it is. Squares, x, 4. One's plus, one's minus. Oh. Aha, they're trying to trick me. Again, you got to wake up earlier. I can take out a 9. Okay, GCF always comes first. Okay, they're trying to trick me there, but I'm too clever for that. Too clever for that. However, the result is still two terms that are all perfect squares. So that's a 2x and a 3. One's a plus, one's a minus, and then there's an outside 9 along for the ride. Okay, here, take out a 2. Okay, now they're perfect squares with the minus in the middle. So that's an x and a 5. One's a plus, one's a minus, with an outside 2 along for the ride. Okay, next one, number 6. I'm assuming that this is going to be cubes. So I'm not exactly sure what the cube root of 216 is. I could use my factoring sheet, or I could use my calculator. What's the cube root of 216? And that answer is 6. All right, so cubes, I cube root everything. So that's an x, that's a 6, and a y. All right, so I have an x, I have a 6y, so I square out, and I multiply to the middle. So x and 6y, I square out, so that's going to be x squared, 36y squared, and multiply to the middle. That's going to be 6xy. The symbols are going to be, this is a minus, so it'll be, again, the same, opposite, always positive. You use SOAP, S-O-A-P, same, opposite, always positive. So it'll be minus, the same, opposite of that is a plus, and then this last one is always positive. Okay, again, cubes. So this is a 2x and a 3. Square out. So that's going to be a 4x squared and a 9. Multiply to the middle. 2x times 3 is 6x. It's going to be the same, which is a plus. Opposite of that is a minus. And then this last one is always positive. Same, opposite, always positive, so a square out, multiply to the middle. I'm just going to take a look at this fraction here real quick. So 343 and 64. Okay. This is a kind of a quick way to see if I can GCF something out of 2 different numbers. Because if they would have said that that fraction is anything but 343 and 64, that means something is coming out of them to simplify. But nothing is going out, so these are exactly what they are. All right, so what the heck is the cube root of 343? Let's take a look at that. So the cube root 343 is 7, okay? So this is 7. Cube root of 64 is 4. X to the third is x. So square out. 7 is 49. 4x is 16x squared. Multiply to the middle. 7 and 4x is 28x. Then it's the same. Opposite. Always positive. So this is an x, this is a 7, this is a y. So x squared, 49y, excuse me, 49y squared. I'm sorry. X times 7y is 7xy. The middle is a minus, so the same is a minus. Opposite of that is a plus, and then this is always positive. Here I can GCF out a n. So that's 343 m to the third plus 64 n to the third. 343 is 7, m to the third is m, 64 is 4, n to the third is n. And square out, so the 7m and the 4n, 7m is 49m squared. 4n is 16n squared. Multiply to the middle, 7 times 4 is 28. M times n is m times n. Symbol is a plus, so it'll be the same. Opposite of that is a minus, and this last one is always positive. There it is.